What's good, everybody? In this video, I'm going to do a complete review on how to simplify expressions. If you find this video helpful, smash the like button for your boy. So problem number one, they give us an expression and they tell us to evaluate the answer or simplify it when x is equal to -3. So what we want to do first is just plug in -3 anywhere that we see x. So that's step number one. Now that we plug this in, we could focus on the parentheses and simplify. So I'm going to get -2, and in parentheses, we're going to have -9 minus 2. When we add those two together, we'll have -2 times -11. And then on this right side right here, when we combine -3 and +9, we're going to get 6 as an answer. So when I finish this problem off and I multiply, I'm going to get +22 plus 6, and I'm going to get a final answer of 28. Now, in problem number one, what they do is they give us a square, a rectangle, I should say, and they ask us to do two things. They want us to find the perimeter and they want us to find the area. So we know with perimeter, guys, opposite sides are equal. So this top side also has to be -2x plus 17, and this left side is going to be 24. So when I add the perimeter, I add all my like terms together, I should get -4x. I know 24 and 24 is 48. Let's see what happens when we add 17 to that. So it should be -4x plus 82. That's going to be my perimeter. Now, if we're talking about area for this problem, that means we're going to multiply. And the best way to set this problem up is let's have 24 on the outside and then put -2x plus 17 in parentheses. Once I multiply 24 and -2x, I'm going to get -48x. And once I go back now and multiply 24 times 17, this is going to give me 408. So this would be the area for this rectangle. Now what we're going to do is look at some different problems in our second example. In this part of the video, guys, we're simplifying expressions that have radicals and exponents. So something we need to know is radical form, and we could switch this to rational form, which would be 64 to the 1/3. But all of these two things are saying, first off, they're the same thing. But what they're saying is, hey, is there a cube root of 64? And there is. The answer would be 4. And the reason why is because when we multiply 4 times 4 times 4, we would get 64 as an answer. That's why there is a cube root, right? Now, our second example, we're talking about properties of exponents, and we notice that when we're multiplying with the same base, we're going to add our exponents, but they throw a fraction in. So let's say we multiply now, right? And we have 8x. Now we're thinking to ourselves, how can we add 3 plus 1/3? Well, if we have a common denominator of 3, I could turn this 3 into a fraction, right? And 9 over 3 is the same thing as 3. So once I add these two together, right, I will get 10 over 3 as an answer. So this is one way you would see the answer expressed. Or if they say, hey, simplify these exponents and write your answer in radical form, now what I would do is include a radical. I know 8x is under the radical, and now we have to understand which number is our power, which one is our root. So we should know that this has a power of 10, meaning it's going to be under the radical, and then our root is going to be right here in that little area right there, the index, just like in this previous problem. So just remember how to switch from radical form to rational form and vice versa. So our next problem now is basically combining like terms. But what they like to do is throw a few curveballs in there. So for one, if we notice, these terms aren't lined up in the same exact order. So we have to pay attention to that. So once we rewrite this, right, let's say we keep it in the same order. We have 60 minus 10d to the third plus 3d squared. After we understand that not all the like terms are lined up in the same order, we now have to take this negative and apply it to each term inside the parentheses, meaning 5d to the third is now negative, positive 3d is negative, and negative 4 becomes positive. So this is something that I see students make a mistake with. Please make sure that you pay attention to that and don't get fooled. So now I'm saying, okay, negative 10d minus 5d is going to give me negative 15d to the third. Then I noticed that 3d squared doesn't have a like term, so we're going to bring it down because it stays the same. Now, the same thing, well, not the same thing. Now we go on to 6d and negative 3d. When we combine those, we're going to get plus 3d. And then the last thing that we need to pay attention to is, hey, we have a constant of 4 and there's nothing for us to add with it. So as a result, we're just going to bring it down and it's going to stay the same. But just be careful in these type of problem, guys, because they're trying to trick us with either the order that they put it in, so we add the wrong like terms, or we forget to change the signs of what comes after the negative sign. And while we're on this, I want to touch on a very similar problem to this. And let's write this problem out real quick. So in the next example, we have 8x y to the fourth minus 7x y to the third minus 11x y to the fourth. So when we look at this, right, everyone says, hey, Mr. Peters, those are all like terms. And don't get me wrong, guys, there are like terms there, but all three terms are not like terms. If we look at the x, y, and the exponents, only the first and last term had the same exact x and the same exact y. So that's the only thing we can add. So once I combine, I would have negative 3xy to the fourth. And because there's no other term with xy to the third, we're going to bring this down. And our final answer would be negative 3xy to the fourth minus 7xy to the third. So this is what I mean when they say they're going to try to throw in curveballs, throw in tricks, and you just have to pay attention to the very small details. So in the next two problems now, guys, we're dealing with simplifying rational expressions, polynomials, same thing. So the first thing we want to do is to simplify. So I'm going to simplify the top as y plus 8 times y minus 2. And then when we go to the bottom of the fraction, we're going to have y minus 9 times y minus 2. Now at this step, we could simplify and cancel out the y minus 2, and our final answer is going to be y plus 8 divided by y minus 9. All right? And then in the second example now, we're going to be talking about the greatest common factor. So when I look at both the top and bottom, in the top I could pull out a 2x, which will give me 4x squared minus 5. And then on the bottom, we could go ahead and pull out a 5x, which will leave us 4x squared minus 5 inside the parentheses. Now that we notice that both of these are the same, right, same binomials, we could cross cancel and we're left with 2x all over 5x. But just remember, guys, that we could cancel out x and take this even further. So our final answer would be 2 over 5. But before we wrap this video up, I'm going to do the same thing with some radicals. So please make sure you guys stick around. So in the next problem now, we're working with distributing, and we're going to pay very close attention to distributing with radicals. So in the first step, we distribute and get x squared plus 4x. And just please make sure you don't forget this negative sign, because we're going to have negative 2x squared plus 16x. Now once we simplify our like terms, we're going to get negative x squared plus 20x as a final answer. All right. But when we distribute with radicals, the process is a little different. So when I multiply 4 radical 5 times 3, the radical 5 is going to stay the same because there's no other radical to multiply it with. So we'll get 12 radical 5. And then when I repeat this step and multiply 4 radical 5 by radical 10, now I'm going to make sure I multiply radical 5 and radical 10 together, but my radical 4 will stay the same. So I'm going to have 4 radical 50. And anytime we have radicals, guys, always double check to see if you could simplify. In this problem, we can. So we have 4 on the outside. Under the radical, we have 25 times 2. We know 25 comes out as a perfect square and it turns into 5. So once we simplify now, we're going to get 20 radical 2, and we're going to bring down 12 radical 5. Now at this step, guys, we are done with the problem because we cannot add these radicals together because they do not have the same number on the radical. But in my last example of the day, let's write this problem out real quick. There's going to be a difference. And this is what I mean. So after we set this problem up, we have a radical and we're going to distribute it to two other radicals. So when I multiply radical 30 and radical 3, I'm going to get radical 90. And when I repeat the process, radical 30 by negative radical 12, we're going to get negative radical 360. Now, in this step, guys, we have to simplify, right? We got to double check. So I'm going to have 9 times 10. This changed to 3 radical 10. And then with 360, let's keep it simple, right? We're going to do 36 times 10. And once we simplify, this is going to be 6 radical 10. Now, unlike this second problem, both of these radicals have the same number underneath it. So as a result, what I need to do now, guys, is just treat the radical like a variable. It's going to stay the same. And we're going to subtract these two coefficients. And my final answer should be negative 3 radical 10 as a final answer. So hopefully this review on simplifying expressions was helpful for you guys. If it was, smash the like button for us, subscribe to the channel, and leave any comments for future videos or even questions you guys had on this video. This is Algebra with Mr. Peters. Thank you guys so much for joining me today.